Fibers are the infrastructure that most pervasively covers our planet. While primarily established for telecommunication, they can also be exploited as a grid of distributed sensors that can be fit for many purposes, from the environmental monitoring to the hazard detection and alerting. So how can we support this transformation? Hi everybody, I am Cecilia Clivati and I am a researcher at the Italian National Metrology Institute, INRiM, and I am the coordinator of the SENSEI project. This is a 3-year project funded by the European Commission under the Horizon Europe program. Within the SENSEI project, we wish to turn the global telecommunication fiber network into a pervasive and distributed sensor, and also to make the network more resilient and efficient thanks to improved monitoring. To achieve this, we will develop photonic techniques that allow us to detect tiny changes in light pulses traveling through optical fibers, and infer from those changes an information about the environment surrounding it. For instance, during an earthquake, the ground shakes, and the fibers that are usually installed in the ground get deformed. We can detect those deformations by looking to tiny changes in the polarization state or the phase of light signals propagating through the cables. However, there is much more than just collecting information. If we wish to develop a global sensing grid, then we need efficient methods to collect, combine, and process such a huge amount of information. We need the ability to interpret the data, and we need an intelligent network architecture that is able to collect and convey the data and turn them into exploitable information, for instance, raising an alarm in case of a dangerous event ongoing. To fulfill this goal, we put together a consortium with different and complementary expertise, from photonic developers to networking experts, geoscientists, and telecom operators. Equipping the network with sensing ability brings huge advantages. For instance, network operators can detect unusual fiber deformation, for instance during construction works, and act before the damage occurs. They can spot anomalies and device failures, enabling to perform predictive maintenance. This will save time, money, and improve the overall quality of the service. In the future, the real-time detection of earthquakes and tsunamis can support the development of early warning systems and helping to protect people and infrastructures. Scientific research would also take advantage from this new approach to sensing. For instance, they will get data from areas of the planet that would otherwise remain uncovered, such as ocean floors that are extremely relevant to better understand the dynamics of our planet. And finally, some of the devices that we will develop in SENSEI for sensing purposes can also be applied to other fields, such as telecommunication, strengthening the synergies between these two fields.